Okay, so let us start with ellipse. So again, as we have discussed yesterday, it's almost more or less the same thing you have in ellipse, which you have in parabola. The extra thing is auxiliary circle. That's all. Okay, but remaining all geometry, parameterization is there in parabola also. 80 square 280. Then chord, focal chord, and all these things, tangents. Mainly these are the important parts. Okay. So let us quickly go. So now, when it comes to geometry of the ellipse, so this is how it is. So ellipse will be symmetrical about two lines. Okay. So this is one line of symmetry. You can see that from the figure itself, it is symmetrical about these two lines. Okay. So the larger line of this one, the line which cuts the larger chord, that one is called major axis. And the one which cuts the smaller chord, that is called minor axis. Okay. So, okay, fine. So overall, the structure is something like this here. So here, x-axis is major axis, y-axis is minor axis. The points which you need to remember is how far will be focus from the center of the ellipse. It is at a distance of AE units. Okay. And how far is directrix from the center of the ellipse? A by E. How far are ends of this one major axis? A. Ends of minor axis? B, small b. Okay, you have to remember those things. Okay. Okay, fine. Now coming back to this one. Yeah, eccentricity, I hope all the formulas you remember. So eccentricity of the ellipse is given by what here? Square root of 1 minus b square by a square. Okay, so where b is the minor semi-minor axis length, this length, a is this one. Okay. Yeah. So all that basic formulas, I'm expecting that you already know it. Okay. Yeah. So let us see this question. Find the equation of the ellipse whose center is 1, 2, focus is 6, 2, and passing through 4, 6. Okay. Yeah. So center is 1, 2 for this one ellipse. So focus is 6, 2. That means just going right side by 5 units, you will get the focus, which is 6, 2. And one point on the ellipse is 4, 6. So let's keep somewhere here, which is P 4, 6. So as you can see, line joining center and focus is horizontal. So the other focus will be on the other side, S dash. So the ellipse will look something like this. So it will be a horizontal ellipse. Okay. Yeah. Now we need this ellipse equation. No? So simple here, what you need to do? You need to find what is, if you know A for the ellipse and B for the ellipse, and the center is alpha comma beta for horizontal ellipse. That means horizontal direction, it is more stretched. For horizontal ellipse, the equation will be x minus alpha whole square by a square plus y minus beta whole square by b square equals to 1. If it is a vertical ellipse, then the equation will be x minus alpha whole square by b square plus y minus beta whole square by a square equals to 1. Okay. Now this is a horizontal ellipse. So below x square, the coefficient will be, below x square, whatever is there, that will be more, that is a square. So a and b we need to find. How to find them? Simple guys. See, in ellipse you have this property. No? What is that? SP plus S dash P will be 2A. Okay. And how to find S dash here? Because simple, midpoint of S and S dash is C only. No? So you can find S dash. That's not a big task. Okay. So SP plus S dash P is 2A. Okay, use that property. You will get the value of A. And what is the distance between these two? AE. No? So you will get AE also. So your AE will be root over 5 square plus 0 square, which is 5. Okay. So you get A, already you know A. So you get E and A. So once you know A and E, you will get the B value also. So you can write the equation like this. Okay. Next. See this question. The ellipse, this one, is inscribed in a rectangle aligned with the coordinate axis. Okay. Which in turn, read this question carefully. So there is an ellipse. So that ellipse is x square by 4 horizontal ellipse plus y square equals to 1. Is inscribed in a rectangle. Okay. Like this. Okay. Which in turn inscribed in another ellipse. The rectangle is inscribed in another ellipse passing through the point 4, 0. Okay. So this is 2, 0. This ellipse. Okay. So it is inscribed in the rectangle is inscribed inside another ellipse they are saying, passing through 4, 0. And they are asking, so like this, the other ellipse can be. They are asking the equation of this ellipse. Okay. See, this is a ellipse whose x-intercept is 4. So can I say the equation will be x square by 16 plus y square by b square equals to 1? Now simple, guys. So we should know additional information about some other information about outside ellipse. Very easy. Why? Because this inside ellipse equation they have given. No? So this is 1 and this is 2. So this point coordinate will be 1, 2, which is on outside ellipse. So this 1, 2 should satisfy the equation. So 1 by 16 plus 4 by b square equals to 1. You will get the value of b square. Okay. Next. There are some more. Okay. Well, yeah, this is very important. Good question. See this one. A circle has same center as an ellipse and passes through the focus F1 and F2 of the ellipse, such that the two curves intersect at 4 points. So what they are saying is, there is an ellipse. Okay. And there is a circle. Yeah, like this. And what they are saying is this circle passes through the foci of ellipse F1 and F2. Okay. And they are intersecting at 4 points. That is what they are saying. Let P be any one of those points of intersection. P be any one of those 4 points of intersection. If the major axis of the ellipse is 17, that is, what is the length of major axis? 2a, na? Not a, 2a. Okay, 2a is given as 17. And the area of the triangle PF1, F2. So what is that one? PF1, F2. This triangle area they are giving 30. Then they are asking distance between foci. Okay, looks like a tough question only. So what they have given, area of triangle PF1, F2 they have given, that is they are saying 30. Then they are asking the distance between foci F1, F2. That means they are asking 2AE is how much? You know already 2A. We need 2AE. That means eccentricity we should know. Okay. Fine. See here, first point. F1, F2 is the diameter of the circle. No? Okay. By symmetry, you can say that is diameter. So can I say that this angle here, it will be 90. And also PF1 plus PF2 will be equals to 2A, na? Which is 17. In an ellipse, sum of focal distances is 2A. So if one is x, if PF1 is x, then what will be PF2? It will be 17 minus x. And what they are saying, the area of this triangle, half into x into 17 minus x, that is given as how much here? 30. So from here you can find x into 17 minus x is equals to 60. Okay. So once you find x, then what is asked? The area is given as 30, then the distance between foci they are asking. Okay. Now once you know x, then what will be distance between foci, f1, f2? Pythagoras theorem, root over x square plus 17 minus x whole square. Okay. That's all. Next. So like this on geometry, there are various questions. Now we'll proceed to tangents. Okay. Yeah. One second, guys. I have kept the questions on. Yeah. So in tangents also, let me just remind you. Okay. So like in parabola, we have like three forms. No? What are those? Point form. Already we have seen, that is point form, slope form, and parametric form. So same way in ellipse also we have these three forms. So where do we use the point form? Pretty straightforward. When a point on the ellipse is given, let's say they have given some point on the ellipse, and you need the equation of tangent to at that point, then simply the point form will help you, that is t equal to 0 or s1 equal to 0, like that. Okay. Now, what is slope form? Very important, guys. Slope form, as we have seen in parabola, again, slope form is majorly used when we are discussing about tangents drawn from an external point. So from external point onto the ellipse, you can draw two tangents. No? Now, if we want to discuss about the slopes of these tangents or anything like that, then we use the slope form. Okay. Now, what is the slope form of tangent for ellipse? Now, forget about ellipse. If you have like even for hyperbola, if the equation of the curve is something like this, then general equation of tangent in slope form is given by y is equals to mx plus minus root over pm square plus q. Okay. So it may be ellipse or hyperbola or circle, whatever it may be. If the equation of a curve is like this, then the general equation of tangent in slope form is given by y equals to mx plus minus square root of pm square plus q, like that. Okay. So let us take some examples. Let's say the equation is x square plus 2y square equals to 4. This is the equation of the curve. Then first you make right side as 1, x square by 4 plus y square by 2 equals to 1. Then the equation will be y equals to mx plus minus square root of 4m square plus 2. This is general equation of tangent in slope form for this curve. Okay. For example, let's say you have x square minus 3y square equals to 6, which is x square by 6 plus y square by minus 2 equals to 1. Always write in the standard form. Right side must be plus 1. Plus 1 it is there. No? And x square by something. Plus must be there in between. Y square by something. So what will be the general equation of tangent? Mx plus minus square root of 6m square minus 2. Correct? Pm square plus q. So this will work for any curve which is of this form. Okay. See, x square by 1 plus y square by 4. Even for vertical ellipse also. Y is equals to mx plus minus, what is p? P is under x square, that is 1 into m square, pm square plus q, which is 4. Okay. So this is general equation of tangent in slope form for a curve which is of this form, x square by p plus y square by q equals to 1. Okay. Sorry. Guys able to see the screen? Can you guys see the screen? Okay, fine. Yeah. Hmm. Yeah, where were we? We were at slope form. Now, last one is parametric form. The parametric form of tangent is pretty straightforward. So it comes from the point form only. So, so in general, if we have any point on the parabola ellipse as a cos theta comma b sin theta, then the equation of tangent to this ellipse at this point, that is, what is the equation of the ellipse? X square by a square plus y square by b square equals to 1. Is already we know it is t equal to 0. So x into a cos theta by a square plus y into b sin theta by b square. So x cos theta by a plus y sin theta by b equals to 1. This is the equation of tangent in parametric form. Now, where do we use the parametric form? Again, if from an external point, if you draw tangents, then in parametric form, you have theta. Na? So theta will be like, if you substitute this point h comma k, let's say from h comma k, you're drawing. So let's say this is q. So from h comma k, you're drawing tangents to this ellipse. Now, the points where this tangents contact will have some parametric eccentric angle. Let's say they are theta 1 and theta 2. So if you substitute h comma k in this equation, parametric form equation tangent, okay, then you will get, you see, once you substitute h comma k, that means you know x, you know y, that you know a, you know b. What will be the variable which will be involved? Theta only, na? So the solution will be these two angles, theta 1 and theta 2. Now, in case of slope form, if you substitute this point h comma k in the slope form, then you see xy we are substituting. We already know p, we know q. What is the variable which will be involved in this equation? M, na? So if you solve it, you will get m. What is m? The slopes of the tangents which are drawn from that point. Okay. So that is what you get if you substitute an external point in the slope form of tangent and in the parametric form of tangent. Okay. So we use in locus questions also parametric form. Anyway, we will see that in problem solving. Okay. So first question, let us see. Find the area of the quadrilateral formed by tangents at the endpoints of lattice rectum of the ellipse. So that means you have this ellipse, then okay, yeah. So what is lattice rectum, endpoints of lattice rectum? You have two foci, na? Then if you draw chord perpendicular to major axis, then these are the endpoints of lattice rectum, P, Q, R, S. Acha, A, B, C, D, let's make it. Already S is there, na? Yeah. Now what they are asking? Now at the ends of lattice rectum, you're drawing tangents. So at four ends, you can draw four tangents. Then they are asking what your area of that quadrilateral. Okay. See, you can see just by symmetry that if you just need to find just this triangle area, that is enough, no? Into 4 will be the required area of the quadrilateral, which is formed by the tangents at the ends of lattice rectum. So let us to find this triangle area, you need to know the tangent equation. So what is the coordinates of point A? Simple, focus is simply at AE comma 0. Focus is at a distance of AE. Okay. Actually, if you see, AE is nothing but A times root 1 minus B square by A square, which is root over A square minus B square. So how far is foci from the center? Root A square minus B square. Root 9 minus 5. What is root 9 minus 5? Root 4, 2. So this focus is 2 comma 0. So x coordinate of focus is 2. And what will be the height of this one? That one end, b square by a, na, that length. Total is 2b square. Length of lattice rectum in ellipse is 2b square by a. So from focus to one end, it will be b square by a. So what is b square? 5. Na? 5 by a. A is how much? 3. So 2 comma 5 by 3. That point. Now how to find the equation of tangent? Now you know the point on the ellipse. The tangent equation will be simply t equal to 0. Na? So x square, you will replace it by x into x1, x into 2 by 9 plus y into 5 by 3 by 5 is equals to 1. So if you simplify, it will be 2x by 9 plus y by 3 is equals to 1. Okay. Now you know the tangent equation. No? So then you will know the x-intercept. You put y0, x-intercept will be 9 by 2 comma 0. If you put x0, you will get y as 3. So this is 0 comma 3. So this length is 3. This length is 9 by 2. So area of that one triangle will be half into 9 by 2 into 3, which is 27 by 4. So all 4 triangles, if you add, it will be 27. No? Okay. Next. There is some passage questions and all. Yeah, this is JEE question. Okay. Yeah, let us see this one. Okay. So let us see the part which is concerned with, this is a passage question, little tough one, but you see, if you just follow the basics, no, it's actually not that tough. Tangents are drawn from 3, 4 onto this ellipse. Okay. So this ellipse, let me draw. Yeah. So you're drawing tangents from which point? 3, 4, no? Yeah. So you can see that this ellipse, if this is x-axis, this will be 3, 0. And if this is y-axis, then this will be 0, 2. Because you can see, na, like if you put y0, x we are getting plus or minus 3. x0, y will be plus or minus 2. Okay. Yeah. Now from 3, 4, they are same. So 3 is like same x coordinate as the end of minor axis. No? So 4 units up we are going. 3, 4 will be somewhere here. Yeah. Now what they are saying, tangents are drawn from that point. Clearly you can see that one of the tangent will be this vertical line only like this. Okay. And the other tangent may look something like this. Okay. Now what do we need? Touching the ellipse at points A and B. So let's say one touching point is A, clear. Another touching point we don't know. Let's say it is B. Then the coordinates of A and B are. A coordinates are 3, 0. That is clear. So I think the answer should be either D or A. One of them. Okay. So obviously from the figure, A is not the touching point because 0, 2 is here. No? So I think D we can conclude it as the correct answer. Okay. But let us find out B, how it is minus 9 by 5, 8 by 5. Okay. Simple. What you do is, now from 3, 4, we are drawing the tangent, correct? Yeah. Now B we don't know. Let's say the touching point is x1, y1. Let's say that is the touching point. Okay. We don't know what is the touching point. Now, let's say x1, y1 is the touching point. Okay. Now what you do is, see guys, this is the general procedure to find the point of contact. Okay. From an external point. What you do is, okay, can we find the slopes of these two tangents? How to find the slopes of tangents drawn from an external point? You have to substitute that external point in the general equation of tangent. What is the general equation of tangent? Y equals to mx plus minus square root of pm square plus q. That is 9 m square plus 4. Okay. Now substitute 3, 4, x3, y4. So 4 is equals to 3m plus minus square root of 9m square plus 4. Take it left side and square. You'll get 9m square minus 8 3 is 24m plus 16 equals to 9m square plus 4. So one slope is anyway undefined only. Now the other slope will be 24m is equals to 12, m is equals to 1 by 2. So this line tangent slope is 1 by 2. Now substitute 1 by 2 here. What do we get? You will get the tangent equation. So y is equals to 1 by 2 times x. Now I should write plus or minus. Plus now, obviously, because the y-intercept is positive, right? Yeah, here y-intercept is positive. No? So plus only we have to write. Square root of 9m square. 9 into 1 by 2 whole square. 9 by 4 plus 4. If I simplify, y is equals to x by 2 plus 5 by 2. That's all. So that is x minus 2y plus 5 equal to 0. What is this? This is the equation of tangent. At which point B can I say? So B I need to find. Na? So B I assumed. So it is like this. You know the tangent to the ellipse. Now you should know where this tangent is touching the ellipse. Correct? So for that, how you should proceed is assume that the tangent is touching at x1, y1. If the tangent is touching at x1, y1, then at x1, y1, the tangent equation must be this only. Okay. So what is the tangent equation at x1, y1? T equal to 0. If you apply t equal to 0, we will get xx1 by 9 plus yy1 by 5, 5 or 4 is equals to 1. So if you simplify, it will be x1 by 9 plus y into y1 by 4 minus 1 equal to 0. Now these two must be same equations. No? I'll just tell you what we have done. See, two statements. If the tangent x, what is the tangent? X minus 2y plus 4 is touching the ellipse at a point B, x1, y1. That means, can I say the equation of tangent to the ellipse at B must be x minus 2y plus 4. So what is the equation of tangent at x1, y1? We have written that is this. And it must be same as x minus 2y plus 5. So compare. So you'll get x1 by 9 divided by x coefficient 1. y1 by 4 divided by y coefficient minus 2 equals to minus 1 here. Constant. There it is 5. That's it. So if you simplify, you'll get x1 is equals to minus 9 by 5 and your y1 is equals to 8 by 5. That is what is there. No? Okay. Then remaining one orthocenter and all that will, okay, secondary part. Okay, next. Yeah, that's it. Normal is not, yeah, in normal you need to just take a screenshot. Actually, this will not be, normally it won't be there in many books. That's second point, B. Okay. Equation of normal with slope M. So equation of tangent with slope M we have seen. No? Now this is equation of normal to any ellipse. The ellipse equation is given like that, x square by a square. Okay, just take a screenshot. I think it should be okay. Because there is one previous mains question exactly directly based on this formula. Okay. So if you are wondering, like, should we remember this formula, sir? Yes, you need to remember. Okay. So why? Because like there was one question, they have given the normal equation. Then they are asking the point of where it is normal and all this thing. Okay. I think I'll just, I think, did I select that question here? Let me see. No. Okay. Fine. Okay, let us see hyperbola now. Almost the same geometry. Almost the same geometry for hyperbola. So just if you are having confusion that what is A, what is B in hyperbola, because in ellipse it is very straightforward, right? For example, if you have x square by 10 plus y square by 9 is equals to 1, whichever is larger, that is a square. Okay, whichever is smaller, that is b square in ellipse. Okay, but in hyperbola that's not like that. Okay, so what you do is, for example, if hyperbola equation is given something like this: x square by 4 minus y square by 3 is equals to minus 1. Some equation is given. So what you do is you put y0. So if I put y0, then what will I get? I'm getting x square by 4 is equals to minus 1, which implies x square equals to minus 4. You are getting imaginary, right? Okay. If you put x0, then what we are getting? Minus y square by 3 is equals to minus 1, which implies y square is equals to 3. So now y you are getting some real quantity, plus or minus root 3. Okay. So which means when you're drawing the figure also, it will be very easy. Hyperbola figure. Why? Because now two cases are there. Na? Either the hyperbola will intersect x-axis like this, or it may be intersecting y-axis. Okay. Now this hyperbola will intersect x-axis or y-axis. How do you decide? Because what we are getting by putting y0, we are not getting any real x. Okay. So that means on this graph, the y coordinate will not be 0. Okay. So y coordinate is not 0 means no point on x-axis. Okay, now you see if you put x0, you are getting some y. Na? That means if x is 0, y is root 3 as well as minus root 3. So this hyperbola will look something like this, opening up and down. Just by substituting x0 and y0, you can find out how the hyperbola looks like. Okay, but anyway, that is not the point. Our point is with how to find a and b. Na? See, always a is the real length, real intercept cut by the axis. See, we discussed in ellipse also, na, the something called axis. Axis are nothing but axis of symmetry. Hyperbola also has two axes of symmetry. Na? You can see one axis of symmetry like this, another axis of symmetry like this. One axis of symmetry will cut the hyperbola, other axis of symmetry will not cut the hyperbola. As simple as that. That's it. Now, the one axis is cutting the hyperbola, na? And it is cutting some length, right? Now, this length is only 2a, that green color one, whichever is there. Okay. Now, nothing to remember, whether it is small or more simple. You can see here clearly that this is root 3, this is root 3. So, your 2a is 2 root 3, or you can say simply say a is root 3. Now, once you know a, the other length is nothing but b. Okay. See, the equation is like this, na? X square by 4 plus y square by 3. We are only confused ki one is 2, one is root 3. Which one is a out of these two? In ellipse, normally it is the larger one. Okay. But in hyperbola, it's the real length. Okay. So root 3 is the real length one, and remaining one is b. So what is b for the hyperbola? 2. Because your eccentricity, everything, the calculations are something like this. Eccentricity is given by square root of 1 plus b square by a square. Okay. So which is root over 1 plus, what is b square here? 4. A square is 3. So square root of 7 by 3. If you reverse it, everything entirely, it will be different. Okay. Root 7 by 4 it will become. Okay. Fine. So let me just give one more example. Let's say we have x square by 9 minus y square by 4 is equals to 1, let's say. Okay. Now, if you put y0, you're getting real, na? Xs plus minus 3. Okay. So that means like this. By putting y0, x we are getting plus or minus 3. So what will be your A? 3. B will be the other quantity, which is how much? 2. From here, everything you can find. Okay. Normally, this confusion will be there for the students. Just I wanted to clear that. Okay. Next, coming to the problems. You see. And one more important point, guys. In case of ellipse, in ellipse, the equation was x square by a square plus y square by b square equals to 1. What is the distance between the center and the focus? It is root over a square minus b square. Okay. Now, in case of hyperbola, the distance between center and the focus will be root over a square plus b square. So, let's say for this hyperbola, x square by 4, y square by 3. Okay. So, how far is the focus from the center? Root over a square plus b square. That means just add these two, 4 and 3, root 7, sorry. How far is the foci from the center? Root 7, and the other foci will be root 7 down, that is 0 comma minus root 7. In ellipse, it is root over a square minus b square. In hyperbola, it is root over a square plus b square. Okay, keep that in mind. Now let us see the first question. The foci of hyperbola are foci of the ellipse. So this ellipse, whichever is there, so I will not draw the ellipse, it will just confuse us. So, but the foci of the ellipse are s and s dash, let's say. And how far will be the foci here? Root over a square minus b square, that is 25 minus 9, root 16, which is 4. So the foci of the ellipse are 4 comma 0 and minus 4 comma 0. Okay, now these are the foci of the hyperbola. Okay, so the hyperbola will look something like this. The eccentricity is 2. Eccentricity of the hyperbola is 2. Then you have to write its equation. Okay, now to write the equation of hyperbola, now this is opening right and left hyperbola. Na? Equation will be x square by a square minus y square by b square equals to 1. So E is square root of 1 plus b square by a square. So b square can be written as a square into e square minus 1. Already they have given e, that is how much? 2. So b square is 3a square. So if you know a square, then everything we can find. Okay, let us see. So for this hyperbola, from center, how far is the focus here? AE, no? That is 4. Eccentricity is how much? 2. So A into 2 is equals to 4. A for this hyperbola is how much? 2. So once you know A, what you know A square, you know B square, that is 3A square. You will get the equation. Okay. Next. So these all are like equation is given, you need to find focus and all, you know those things. Okay, let us see. The foci of the ellipse and the hyperbola coincide. Again, it's very simple. So that means hyperbola, how is it here? If you put y0, x, you are getting some real quantity. Na? So this is how the hyperbola is. So how far will be the foci of hyperbola? Yeah, so this is 25, or you can write x square by 144 by 25 minus y square by 81 by 25 equals to 1. So how far will be foci? Root over a square plus b square, 144 by 25 plus 81 by 25. So which is square root of, this will be 225 by 25. So this one, this 5's, not 5, 9. So which will be 3. Okay. So what are the foci of hyperbola? 3, 0 and minus 3, 0. And foci of ellipse also will coincide. How far will be foci of ellipse? Square root of a square minus b square. Square root of 16 minus b square. So square root of 16 minus b square must be equals to 3. So 16 minus b square is equals to 9, which implies b square is equals to 7. Now this is the AIEEE question, mains question. Okay. Next. This is IIT JEE question, again on geometry only. You read the question. A hyperbola passes through the foci of this ellipse. Okay, let me just mark the foci of this ellipse. Again, you see how many questions are there based on just foci and all. So how far will be foci of the ellipse from the center of the ellipse? Root over a square minus b square, which is root 25 minus 16, which is 3. So foci are 3, 0 and minus 3, 0. These are the foci of ellipse. Now what they are saying, a hyperbola passes through this foci. Okay, so the hyperbola will look something like this. Yeah. Okay. Yeah, its transverse and conjugate axis coincide with major and minor axis. Yeah, you can say that. Okay. Uh, Next, then the equation of hyperbola they are asking, first thing. Okay. And also the product of eccentricities is 1 they are saying. What is the eccentricity of the ellipse? Square root of 1 minus b square by a square, 16 by 25, which is square root of 9 by 25, which is 3 by 5. So what will be the eccentricity of hyperbola, which will be 5 by 3, no? Product is 1 they are saying. Okay. And for hyperbola, you can clearly see this is that a value, no? Because the point where the hyperbola intersects from center, the distance is a. So a for the hyperbola is indirectly given, that is 3. And eccentricity for hyperbola is given indirectly, that is 5 by 3. So your b square is a square into e square minus 1. So you know a, you know eccentricity. You can find b square. Then the equation is x square by a square minus y square by b square. That's all. Okay. Next. A hyperbola having transverse axis length. What is transverse axis length in hyperbola? 2a. That is 2 sine theta. That is a sine theta. And what they are saying, it is confocal with this ellipse. What is the ellipse? X square by 4 plus y square by 3 equals to 1. It is a horizontal ellipse. Okay. One second. Yeah, it is horizontal ellipse. What is meant by confocal? Same foci. Okay. What is given in the question? Let me just read it again. A hyperbola having a as sine theta is confocal with this ellipse. Okay. So hyperbola and this ellipse will have same foci. So what are the focus of this ellipse? Foci of this, how far will be the ellipse from the center? Root over a square minus b square, which is 1 unit. So foci are 1, 0 and minus 1, 0. Okay. And already they have given a. So for hyperbola, how far will be the foci? Square root of a square minus b square. And that is 1. No? The distance of focus from the center of the hyperbola is 1. Because confocal, same focus for hyperbola. And already a they are given. So sine square theta minus b square is equals to 1. So b square is equals to minus, so root a square plus b square. Yeah. So b square is equals to 1 minus sine square theta, which is cos square theta. So for hyperbola, we got both a square and b square. The equation will be x square by a square sine square theta minus y square by b square cos square theta is equals to 1. That will be the answer. Okay. Next, asymptotes. Asymptotes, only very simple, guys. Actually, what you need to find about the asymptotes is, if a hyperbola is given, x square by a square minus y square by b square is equals to 1. Or the hyperbola equation can be x square by a square minus y square by b square is equals to minus 1. Then the asymptotes for this hyperbola, just constant you keep 0. That's all. That means if you know hyperbola, how does it look? No? So hyperbola looks like this. Okay. The lines which are almost like tangent to the hyperbola at infinity, these are only called asymptotes. Okay. So if you have a opening right and left hyperbola or up and down hyperbola, so whatever it may be, the equation will be either like this or like this. Then just constant, if you put 0, then you will get the asymptote equations. Okay. Let me take one example. Let's say this hyperbola equation is x square by 4 minus y square by 1 is equals to 1. Okay. Then you put this constant 1 to 0. What do you get? X square by 4 minus y square is equals to 0. So which means x by 2 minus y into x by 2 plus y is equal to 0. So y is equals to x by 2, y is equals to minus x by 2. These will be the two asymptotes. So this is y equals to x by 2, one line asymptote. Other asymptote will be like this, minus x by 2. Okay, that is how you need to write the equation of asymptotes for standard equations like this. Okay. Now there is a method for general equation also, but for mains it is not required. It is a bit lengthy. Okay. It is based on pair of straight lines condition. Okay. So right now I don't want to discuss. It is unnecessary. Okay. Yeah, it is another point of information which you can just store, but you will never be using it. Okay. So leave that one. Okay. So let us just see some questions. Yeah. For example, okay, fine. So let us just see. They have given the hyperbola. Let's say something like this. Now this is not like a standard hyperbola. X square by a square plus y minus y square by b square is equals to 1. So where if they are asking asymptote, you put this to 0, you will get the answer. But this is not the standard hyperbola, no? But still, how to find the asymptotes here? What you do is, the point is simple. The hyperbola equation and asymptote equation, they differ by a constant, that's all. You see here, hyperbola equation is x square by a square minus y square by b square minus 1 equal to 0. What will be the asymptotes? X square by a square minus y square by b square equal to 0. What is the difference? Just the constant. No? So if they have given the hyperbola equation, that means the asymptote equation is going to be simply almost the same, 5xy plus 2y square plus 4x plus 5y, but only thing is plus c equal to 0 you have to write. Okay. Now what are asymptotes? Asymptotes are nothing but pair of straight lines. Okay. Here you see, by putting 0, na, what we are getting? We are getting pair of lines only. Na? Here, one line, second line. Okay. So asymptotes are nothing but pair of straight lines. Okay. So that means this should be a pair of straight line equation. And what is the condition for an equation to be pair of straight lines? Delta must be 0, which is det of AHG HBF. This you learn in pair of straight lines. Na? GFC. Condition for a given equation to be pair of straight lines. If this delta is 0, then the given equation will be pair of straight lines. Then you will get the value of C. That means you will get asymptotic equations. Okay. Again, as I'm saying, it is not so much necessary, guys. Okay. That's why. Now, next one is parameterization. I will quickly go to tangents. Actually, tangents is the important part again. Okay. Yeah. So again, in case of hyperbola, we have like point form, slope form. Okay, parametric form, same thing. Okay. Point form means if a point on the hyperbola is given, like this, like this, the hyperbola is na. So if a point on the hyperbola is given, the equation of tangent p equal to 0. Okay. Slope form, already we have seen whether it is an ellipse or hyperbola. If the equation of the curve is of the form x square by p plus y square by q equals to 1, then the equation of tangent in slope form will be mx plus minus square root of pm square plus q. Okay. Parametric form is simply just take the ellipse x square hyperbola. Write the equation of tangent at a general point a secant theta comma b tan theta. If you do that, you will get x by a secant theta minus y by b tan theta equals to 1. So this is only parametric form of tangent. Yeah. So mainly we will be using point form and slope form. Parametric form normally we use in generally locus questions. Leave that one. So where do we use the point form? If a point on the ellipse hyperbola is given, you need the tangent, you use the point form. Where do we use the slope form? Slope form is used when from an external point, if you're drawing the tangents, then you will use the slope form to know the slopes of tangents drawn from this outside point. Okay. Let us see some question. Yeah. Locus question only. Yeah, let us say they have given, just we need only half of the question we'll solve. That is the equation of tangents to this hyperbola from 3, 2, let's say. Okay. Now, the hyperbola equation is given by x square by 9 minus y square by 1 is equals to 1. Okay. So the hyperbola means it will look something like this. So this is 3, 0. This is minus 3, 0. So from which point you are drawing the tangents? 3, 2. So like this from above, just like in the that question only, in ellipse question. One tangent is straight away, we can say it is like this. Okay. Now the other tangent we need to find. Okay, let us see. So what is the general equation of tangent? Y is equals to mx plus minus square root of pm square, 9m square. Now this is plus, here minus 1 I can write now, minus 1. Substitute 3, 2. 2 is equals to 3m plus minus root 9m square minus 1. Simplify, 9m square minus 12m plus 4 is equals to 9m square minus 1. Okay, one slope is undefined. That's why we are getting only one root. 12m is equals to 5. M is equals to how much? 5 by 12. So the other tangent slope will be 5 by 12. Okay. Now, once you know the slope, then you will get the equation. Okay. Now, once you know the equation, then you can get the point of contact. We have seen how to find point of contact. Okay. Compare it with t equal to 0. Okay. Next. So it's the same thing, whatever is there in the ellipse. Same thing in case of tangent also we'll get. From an external point, you need anything. Okay, you substitute in the slope form. That's all. Okay. Next, normal of the hyperbola. Normal of ellipse, we have seen the equation. No? Now you see, note it down this one. All three are important. If any point is given directly, you need to write the normal of the hyperbola. Then it is like this. Okay. Fine. So yeah, that's it here overall, more or less for today. Okay. So ellipse and hyperbola. So just concentrate on geometry, that is finding eccentricity, focus, and all these things, and tangents. That's all. Majorly from these two regions only the questions are coming in ellipse and hyperbola. Okay. Okay, guys. So we'll stop the session today. Okay. Fine. We'll continue. Yeah, I will share. Yeah, I'm sharing it. I'm sending it to the in charge. Okay. They have to share it with you. I'm sending it. Yeah. Yeah. Okay. Yeah. Yeah. Okay. Thank you, everyone. We'll continue again tomorrow, guys. Okay. I think tomorrow is physics. I think. Yeah. Physics or chemistry. Chemistry. I think. Yeah. So day after tomorrow or something like that, maths again will be there. Okay. Chalo. See you then, guys. Okay. Bye. Thank you, everyone.